Hi class, and welcome to Module 4 Part 2. So we're not going to be learning anything new, we're just going to continue to do more examples on hypothesis testing. So what is a hypothesis test? So remember, in a hypothesis test, we are testing a claim to be applied to an entire population. You can test a claim about a population proportion, a mean, a standard deviation, or a variance. Going over the steps again. So steps 1 through 3, that's where I'm going to be writing my null hypothesis. And remember, your null hypothesis is the accepted fact. And then you have your alternative hypothesis. That's what you as a researcher are claiming to test. So again, those steps are to identify the claim to be tested, write it in symbolic form, and identify the null and alternative hypothesis. Okay, so your null hypothesis. I am what is, the default, the status quo. I am already accepted, can only be rejected. The burden of proof is on the alternative. I am the null hypothesis. Okay, step 4 of your hypothesis training. Here's where you select your significance level, and that's your alpha. So in practice, we either take 5% or 1% level of significance. What that translates to is a 95% confidence or a 99% confidence respectively. So if I'm 95% confident, my alpha is 5%. If I'm 99% confident, my alpha is 1%. Okay, so for example, we are about 95% confident that we have made the right decision. Caution. Okay, so when thinking about the significance level, make sure you take into consideration if it's two-tailed, right-tailed, or left-tailed. Okay, step 5, this was where we identify the test statistic. So if you recall, we would use a Z statistics if you know sigma. That's the population standard deviation. Again, that is extremely unusual that we would be using it. We typically always use our T statistics. And again, that means if we don't know sigma, that's when we use that T statistic. And the equation, just like what we did in part 1, is this right here. So X bar, remember that is your sample mean minus mu, which is the population mean, divided by S. S is your sample standard deviation, and then the square root of n, where n is your sample size. When you're in Excel, make sure you use parentheses. Okay, for part 1, you guys saw me make a mistake where I did not use my parentheses correctly, and we resulted in an order of operation error. So always use the parentheses with the top, then the numerator, and then the parentheses with the bottom. Okay. Steps 6 and 7. This is where you're going to answer whether you should reject or accept your null hypothesis. Okay. We learned 2 different values. You have the p-value method or your critical value method. Both are going to garner the same result. So if you do the p-value and you get it, you reject. If you do the critical value method, it should also reject. They're always going to be the same. Okay, so again, those steps are you need to find the value. So if I'm doing the p-value method, I need to find my p-value. If I'm using the critical value method, I need to find my critical value. And then 7, this is where you make a decision. Okay, so either way you reject or fail to reject your null hypothesis. And again, we'll go over that criteria again, but that's the same thing from part 1. Okay. So steps 6 and 7, again, this is if you're using your critical value method. So pre-work determine if it's two-tailed, right-tailed, or left-tailed. Again, that's all dependent on if it's less than, we'd use left-tail. If it's greater than, right-tailed. And if it is the does not equal, that's where we use the two-tailed. So find the critical value depending on the type. So if one-tailed, left or right, you're going to end up using, so this is a little bit of an error here. So if it's one-tailed and it's left, I'm just going to draw this right over here. So if it's left, you want to make sure you use the T inverse alpha, and remember that's your degrees of freedom. The right is the 1 minus alpha. Okay, so make sure you fix that in your notes. So the left, again, and that was it's correctly written in your Module 4, Part 1. Okay, and then if it's two-tailed, you just want to use the 2t with that. If you're a visual person, drawing a graph with the critical value, determine the rejection region. Okay, and then make a decision to either reject the null hypothesis or not. So you're going to reject it if the test statistic falls into the rejection region, and you fail to reject if the test statistic does not fall into the region. Okay? And again, that's just when you look at your values. You're going to compare your critical value with your test statistic, whether it's less than or greater than. Okay? So with your p-value, so this is the p-value method. Use the t-distribution function to find the probability of the test statistic. That's found in step 5. And again, you're going to make a decision to either reject the null hypothesis or not. So if your p-value is less than or equal to alpha, you reject the null hypothesis. If the p-value is greater than alpha, then we fail to reject the hypothesis, okay, the null hypothesis. So little thing, if the p is low, then the h sub o must go, okay, because your h sub o is your null hypothesis. Okay, and then step 8 is you restate the decision in non-technical terms. So if you reject the null hypothesis, you should conclude there's sufficient evidence to support the claim that, then you state the original claim. If you fail to reject the null hypothesis, you should conclude there is not sufficient evidence to support the claim that, and then again you write the original claim. One thing to note, when you are failing to reject the null hypothesis, this does not mean we are accepting it. It just means we haven't proven the null hypothesis, so we cannot accept it. Okay. So we're going to go ahead then and we're going to do 3 more practice examples. In your deliverable, you are going to be using both methods, the p-value and the critical, so we're going to do that as well with this problem. Okay, so a little bit older, gonna have to zoom in a little bit. So a biologist was interested in determining whether sunflower seedlings treated with an extract from Vinca minor roots resulted in a lower average height of sunflower seedlings than the standard height of 15.7 centimeters. The biologist treated a random sample of n equals 33 seedlings with the extract and found the sample mean to be 13.664 and the sample standard deviation to be 2.544. Okay, so we're going to have to go ahead and do this. So we're going to kind of write it out the same way. So you have steps 1 through 3. That's where we're going to do the null and the alternative hypothesis. So my null, that's your h sub o. So I have mu. So my mu, remember, that's going to be what is accepted. Okay, so what's accepted is it has a standard height of 15.7. So this is equal to 15.7. What I want to see, so my alternative, h sub 1, is that mu is less than 15.7. Okay, because I said it resulted in a lower. That's what he thought. Okay, so that's steps 1 through 3. Step 4, that's where we have our alpha. Okay, well, in this case, it is not specifically given. So we said when it's not specifically given, we're going to say use a 95% confidence interval. So alpha would be 0.05. Okay, so now we're going to go to step 5. So step 5, this is where we either using a z or a t statistic. Well, I'm looking and it says here sample. So, and then I have a sample mean, sample standard deviation. That means I do not know my population, so I must use a t statistic. if you recall your t statistic, again, that's x bar minus mu all over s square root of n. Now what I'm going to do as well is I'm going to make sure I notate everything, all the variables. So I have my mu, and let's go back. So my x bar in this case, so what is the sample? Well, my sample in this case is, he noticed it to be 13.664. My sample standard deviation is 2.544. I know that my mu, we already wrote that, but that's 15.7, and my sample is 33. Okay, so now we're going to go ahead and we're going to calculate this in our Excel. I'm going to pull up Excel. Now what I did is I already just kind of filled this stuff out, so I have it ready. Think about it with your deliverable 4. You're using that data from deliverable 1, so you have this information in. Okay, so think about your deliverable. If you're practicing at home, you can just open an Excel, pause the video if you want, fill it in like how I have it, and then go ahead and answer. Remember, we need that degrees of freedom. Remember, that's equal to n minus 1. Go ahead and enter. Okay, so what I'm going to do right now is I'm going to find my test statistic. So that is equal. Make sure I use my parentheses. Okay, so it's my x bar minus my mu, close the parentheses, divided by parenthesis, my sample standard deviation divided by the square root of my sample size, and now I'm going to close those parentheses and hit enter. So here I get negative 4.59746. Okay, so that would be, I'm just going to go ahead, which is approximately negative 4.597. Okay. Now step 6, so again, I'm going to use both. So this on the left, I'm going to go ahead and do the critical value method. So remember, your critical value, to find that, that is your t inverse of your alpha and your degrees of freedom. So let's go ahead and go to Excel. So I have equals t dot inverse. Okay, so my probability, so that's my alpha, my degrees of freedom, and hit enter. So I get negative 1.69236. Okay, so now let's go ahead with step 7. So with step 7, I'm comparing my t statistic to my critical value. Well, I'm noticing that the t stat, which is equal to negative 4.6, is less than my critical value, which is equal to negative 1.69. So what does that tell me? Well, if I was looking at my notes, when it's less than, that means we reject the null hypothesis. Okay. And then what I'm going to do is I'm just going to hold off on step 8, because that's where we write our sentence in a non-technical way. But I want to confirm with the p-value, because again, you're going to have to do both. So I'm going to go ahead and do step 6 again, but this time we're going to use our p-value. So the p-value, so that's your t dot distribution. Now it is less than, okay? So that's one thing I forgot to mention here. I was less than, so I did use the left tail, so that's how I knew to use that equation. So then again, that's your t, your degrees of freedom, and then it is always true. Okay, so our p-value, so we have equals our t dot. Okay, so my x in this case is my test statistic that I found. Go up to my degrees of freedom. And then again, it is always true. Okay, so I get 3.1885 e to the negative 0.5. So again, remember that means it is a very small number. It's written in scientific notation. That decimal means I'm moving it 5 to the left. So this is equal to 0.0000318. So as you can tell, it is a very small number. So now we'll go to step 7. This is where we compare our p-value with our alpha. So our p-value there is less than alpha. So what that tells us, again, we just comparing it, if the p-value is less than alpha, this means we reject the null hypothesis, which it should match, which it did, because again, when you do, whether you do the critical value or the p-value method, you're going to get the same answer. So we got the same answer. We know we did this correctly. Now I'm just going to write my answer. Okay. So there is sufficient evidence to support that sunflower seedlings, and this is just going to be a long sentence, treated with an extract from the Vinca minor roots resulted in a lower average height of sunflower seedlings than the standard height of 15.7 centimeters. Okay, so kind of a long sentence. Go ahead and pause it here if you need to take a second to copy that down. But again, we just kind of going over these steps 1 through 3, we identified the null hypothesis and then our alternative hypothesis. Next one we did was our alpha. We used a t-statistic because our population standard deviation was unknown. I'm doing both the p-value and the critical value because that's what we want to do in our deliverable. We get the same result. And then for step 8, we go ahead and write our answer in non-technical terms. Okay, so hopefully this was a great review, and we just have 2 more reviews left. So at any time if you want to practice these on your own, pause the video before I do that next example and then come back and check your work. Okay, example 2. The administrator at your local hospital states that on weekends, the average wait time for the emergency room visits is 10 minutes. Based on discussions that you've had with friends who have complained on how long they have waited to be seen in the ER over a weekend, you dispute the administrator's claims. You decide to test your hypothesis. Over the course of a few weekends, you record the wait time for 40 randomly selected patients. The average wait time for these 40 patients is 11 minutes with a standard deviation of 3 minutes. Do you have enough evidence to support your hypothesis that the average ER wait time exceeds 10 minutes? You opted to conduct the test at a 5% level of significance. Okay, so let's go ahead and get started. So steps 1 through 3, this is where we want to state our null and our alternative hypothesis. So our mean, do we know the mean? Well, we know that the average wait time is 10 minutes. So our mean is equal to 10. My h sub 1, we think that it exceeds 10 minutes. So that means that I think the mu is greater than 10. Step 4, this is our alpha. So we have a 5% level of significance. Again, 5% level of significance is the same thing as saying 95% confidence level. So that means my alpha is 0.05. Okay. Now I'm going to go ahead and compute the t statistic because I don't know. So step 5, are we using t or z? Well, they don't mention anything about the population standard deviation, so I'm going to use a t statistic. Okay. So again, we're going to have to go to our Excel to do that. Again, let's just write some information down. So again, we know mu is 10. The sample in this case, so the average wait time for 40 patients is 11. So when we did our sample mean was 11. I know we had 40 patients, so that was my sample size. And then I need S, which is my sample standard deviation of 3. Okay. So let's go ahead and go to Excel. Okay, so again, I have all this information in here. Now I'm going to go, except for my degrees of freedom, so equals n minus 1. Okay, so I'm going to do my t statistic. So this is equal. Remember, parentheses are key. So I have my x bar minus my mu, close the parentheses, divided by parentheses, my sample standard deviation, divided by the square root of n, close those parentheses, and hit enter. So in this case, I get 2.108. Okay, so again, steps 1 through 5 are the same whether you use the critical value or the p-value. Now I'm going to go ahead and go to step 6, just doing the same thing. So I'm going to start with my critical value. Okay, well this time it is greater than, so I have to use the t inverse, okay, of 1 minus alpha, and again that's my degrees of freedom. Okay, so let's go in here. So t inverse, and then my probability. So that is 1 minus my alpha. Okay, and my degrees of freedom. Hit enter, so I get 1.68. And I think I went a little too fast. Let me just remember. So again, that's how I got it there, because I had to do that 1 minus, and then the alpha, 1 minus alpha, degrees of freedom. So 1.684, round to 1.68. Okay, so now the next step here, step 7, is I'm going to compare my t statistic with the critical value. So I know my t statistic is greater than the critical value. So when your t statistic is greater than the critical value, you reject, okay, the null hypothesis. Okay, I'm just going to go over here and write that down. Okay. And remember, the reason why Okay, I'm rejecting it because again, and you're probably like, well, on this example, just to clear this up, because I know that would be a question. Well, on step 7, it was less than, so rejected. Why is it if it's greater, rejected? But remember, with step 7, we're using a right-tailed. Okay, so we got to look at the information for the right-tailed. There's one of the sheets that I gave you guys underneath the notes that summarizes everything there for you. So again, I'm looking at that right-tailed information, and if it's right-tailed, if your test statistic is greater than your critical value, you reject the null hypothesis. Okay, so let's see, does that match? So I'm going to go ahead and do step 6, but this time I'm going to do the p-value. Okay, so again, for my p-value here, okay, it is the same thing as if it is left-tailed, just so you guys know. Okay, it's only different if it's two-tailed. Okay, so let's go ahead and plug that in. Okay, so I get .979. Okay, so I have an error here. Should be 0.02. So go ahead and pause the video because I have something incorrect on here. Oh, wait, I know what I did. Okay, so I just didn't finish it. So the p-value, right? So I have that. Now I do have to, because it is right-tailed, I have to do 1 minus. Okay, so there's that. So now I'm going to do equals 1 minus and hit enter. There's my answer. That's why it's 0.02. So sometimes even I have too many equations and then formulas going in my head. It's easy sometimes to mix them up, but that's why we have those nice sheets in front of us. Okay, so again, because it was right value, you're still going to do that. It's just going to be 1 minus. So this right here is my answer. So I'm going to go over here and fix that. So it's 1 minus. There we go. So then we ended up getting 0.02. Okay, and then step 7. Again, we're going to compare now our p-value with our alpha. So our p-value is less than alpha. So when that happens, we reject the null hypothesis, which again, these need to match. Perfect. So now we can go ahead and step 8, write our answer in non-technical terms. So since we're rejecting it, that means there is sufficient evidence. That the average ER wait time exceeds 10 minutes. Awesome. Okay, sorry for that little error on step 6, but we did catch it. So that's always a good thing too. When you notice something looks wrong, then you go back and look and go, oh, okay. Okay, one more. So again, go ahead and try this on your own and come back and pause the video. Okay, so A clinical trial was conducted to test the effectiveness of the drug zopiclone for treating insomnia in older subjects. Before treatment with zopiclone, 16 subjects had a mean wake time of 102.8. After treatment with zopiclone, the 16 subjects had a mean wake time of 98.9 minutes and a standard deviation of 42.3. Assume that the 16 sample values appears to be from a normally distributed population, and test the claim that after treatment with zopiclone, subjects have a mean wake time of less than 102.8 minutes. Okay, so steps 1 through 3. So the null hypothesis is, so before the treatment, they had a mean wake time of 102.8. So mu is equal to 102.8. And I'm just going to go ahead and write this up here so I know that, 102.8. And what do we want to prove? Okay, so what is that alternative hypothesis? It is a Friday, I'll tell you that much. Okay, so we want to claim that, okay, that they have a wake time of less than 102.8. So we want to claim that mu is less than 102.8. So again, since it's less than, that means we're using that left tail. Step 4 is our alpha. Well, it doesn't specifically say, so then our alpha, we're going to do the 0.05. Step 5, okay, well, looking at here, I don't see a sample standard or a population standard deviation, so that means we're going to be using our t-statistic. Okay, so let's get that information out there. Okay, so I'm noticing that our participants are 16. When we ran it, okay, they had a mean wake time of 98.9, so x bar is equal to 98.9, and my sample standard deviation was 42.3. Okay, so let's go ahead and go to Excel. And I'm going to go ahead and do this. Okay, so we're going to go ahead and do our t-statistic. So equals, again, careful with those parentheses. So I have my x bar minus the mu divided by, again, make sure you have the parentheses, sample standard deviation divided by the square root of my sample size. Hit enter. Okay, so I get negative 0.36, okay, 4. Step 6. Okay, so again, I'm going to start with my critical value. Okay, so to find that, so it's equal to my t inverse. Okay, and again, I have my alpha, and then my degrees of freedom. Okay, so I get negative 1.753. Okay. And then step 7, I want to compare my t-statistic with my t-statistic, looking here, that is bigger than my critical value. So that's telling me to not reject my null hypothesis. Okay, so we did that. Let's go ahead and check it with the p-value. So let's go over here. I'm just going to change colors. So step 6 again, but this time with my p-value. Okay, so again, it is a left. So I'm just doing the equation like normal. So equals dot distribution. Okay, I have my t-statistic my degrees of freedom. And again, that's true. Okay, so I get 0.360. Okay, so now I want to compare my p-value with my alpha. Well, that is going to be bigger, so my p-value is greater than alpha. So again, looking at that information with a left-tailed, that means I'm not going to reject. So do not reject. Okay, perfect. They matched up. Now we can go ahead and write our answer in a non-technical way. So there is not sufficient evidence to support the claim that after treatment with the drug sopicolone, subjects have a mean wake time of less than 102.8 minutes. Okay, so hopefully these extra examples will help you with those deliverables for Module 4. Again, if you have any questions on the material, feel free to join me in any live session or email me